Yes, children, let us see today physical properties of alcohols and phenols. Okay, now the properties of alcohols and phenols are mainly due to hydroxyl group which is present. Like alcohol, you write it as ROH, and phenol, you put OH group on the benzene ring. So it is this alcoholic group, that is OH group, which is deciding the properties of alcohols and phenol. So the nature of R group that will only modify these properties. Now let us first see boiling point of alcohols. Now we have studied in RX also that boiling point of the members belonging to a particular series, they increase with increase in the number of carbon atoms. The same way here also, boiling point of alcohol increases with increase in the number of carbon atoms. So you can expect methanol having the lowest boiling point than ethanol, than propanol, like this. Because the molecular mass is the least for methanol and it is the highest for propanol. So boiling point increases with increase in molecular mass. Boiling point increases with increase in molecular mass. So this is number one. Then number two, what you can say, boiling point decreases with increase in branching for isomeric alcohols. Say you have butanol, then you have butan-2-ol, and you have terbutyl alcohol. Now you will find the number of carbon atoms same in all the three cases. Here also it is 4 in number, here also it is 4 in number, here also it is 4 in number, and the molecular mass is also the same. So these are called as isomeric alcohols. They have the same molecular formula but they have different structural formula. So here boiling point decreases with increase in branching. Now why it is decreasing with increase in branching? That is because with increase in branching, the molecule assumes a spherical shape, and you know very well that between two spheres the area of contact is minimum, right? The area of contact is minimum when you have two spheres. That is why the magnitude of van der Waals forces will be less, and hence boiling point will also be less. That is why you say boiling point decreases with increase in branching, because boiling point is attributed to intermolecular forces of attraction. So when the intermolecular force of attraction is decreasing, then boiling point will also decrease. So magnitude of intermolecular forces decreases with increase in branching. So this is what you have to understand very clearly. Now when you consider, say for example, you have molecular mass is same. Say you have C4H9OH. This is alcohol. Now if I put it this way, C2H5O C2H5. Now here also you have 4 carbon atoms, 10 hydrogen atoms and 1 oxygen. Here also you have 4 carbon, 10 hydrogen and 1 oxygen. This is alcohol, this is ether. Right? Now when I consider say C4H10, which is butane. Now when you consider the boiling point of these three, this is alcohol, this is ether and this is alkane. Now alcohol will have higher boiling point than ether and ether will have higher boiling point than alkane, and the molecular mass is almost the same. So here why boiling point is more here? This is because of intermolecular hydrogen bonding in alcohol, which makes the boiling point much higher, and here there is no intermolecular hydrogen bonding because hydrogen is attached to carbon and it is not attached to oxygen. That is why there is no intermolecular hydrogen bonding, and a little bit of polarity is there. Here also polarity is there. Here also polarity is there, but here the polarity is less, and this is totally non-polar, and there is no intermolecular hydrogen bonding among alkanes as well. So the magnitude of attractive forces, that is deciding the boiling point. Since there are intermolecular hydrogen bonding and also polarity, you will find the boiling point of alcohol much higher than that of ether and much higher than that of alkane. So this is one set of physical property that you know that you have to understand with respect to boiling point, especially when you have boiling point with reference to almost similar molecular masses, how you have to decide. Now it has been shown that ethanol CH3 CH2OH, then you have CH3OCH3. Now again here the molecular mass is same, both of them are having 46 as the molecular mass, and the boiling point of alcohol is 351 Kelvin and that of ether is only 248 Kelvin. Now if you consider similar molecular mass, that is with respect to propane CH3, CH2, CH3, this is having a molecular mass of 44 and the boiling point is only 231 Kelvin. So you find here alcohol much greater than ether, ether much greater than alkane. So intermolecular hydrogen bonding is there in alcohol, it is not there in ether, it is not there as well in alkane. So the magnitude of intermolecular hydrogen bonding is making the boiling point of alcohol much larger than that of ether, than that of alkane. Now let us come to the next property, that is solubility. The next one, let us talk about solubility. Now again here also solubility of alcohol in water is due to their ability to form hydrogen bonds with water. So solubility of alcohol in water is more. Say for example, if I show you methanol, you can show the intermolecular hydrogen bonding through the lone pair of electron on oxygen of alcohol with hydrogen of water. Same way the other lone pair can also be attached to another hydrogen of another water molecule. So this way this can be attached to different water molecules, and that is why the solubility of alcohol is more. But then solubility decreases with increase in the size of alkyl chain. That is, you say that methanol is much more soluble than ethanol, which is much more soluble than propanol, like that it goes. So here the magnitude of alkyl group, the size of alkyl group, that will decide the solubility. This will be highly soluble and this will be least soluble. So the size of alkyl group, if it is more, then the solubility will be less. So you say in general alcohols are miscible with water in all proportions. In general, with the size of alkyl group, if it is smaller, then the solubility is much greater. Now when you consider that of phenol, in the case of phenol, the solubility is less than that of regular alcohol. That is because of, in the case of phenol, you have the bulky benzene ring, because of which the solubility decreases. So this is about the properties, physical properties of alcohols with reference to boiling point and solubility. Now there are a few questions which are given in your textbook. Example question, you have been given, say, you have, say, pentanol, then you have butanol, and then you have butane-2-ol, say then ethanol, then propanol, like this. Now how would you arrange them? Here you have to arrange them in terms of magnitude of intermolecular forces. So here this is with reference to boiling point. So what you will find? You will find methanol, boiling point of methanol is much lower than that of ethanol, much lower than that of propanol, and then propanol is lower than that of butane-2-ol, and then this is less than that of butane-1-ol. Now here there is branching because OH group is attached to the second position. Here OH group is attached to the first position. So with branching, increase in branching, boiling point decreases, we already saw. That is the reason butane-2-ol is having lesser boiling point than that of butane-1-ol. Now another set of compounds, that is, you have been given pentanol, and then you have been given N-butane, and then you are given ethoxyethane. Now in this case, which will have the least boiling point? Obviously this one, because this is an alkane, this is ether, and this is alcohol. Now we have already seen in the case of alcohol, polarity is also there and intermolecular hydrogen bond is extensive. In the case of ether, there is no intermolecular hydrogen bonding and it is much less polar than that of alcohol. And here this is non-polar and there is no intermolecular hydrogen bonding as well. So you will find that in this case N-butane has the least boiling point then you have ethoxyethane, and then you have pentanol. Alcohol will have highest boiling point, right?